Today we will be discuss about UPS. At first, what is the full form of UPS? Uninterruptible Power Supply. So this is the contents part. Introduction about UPS, various parts of UPS system, and block diagram of UPS system, waveform of UPS system. What are the types of UPS system? Then last part is applications and inverters. Okay. So now comes to introduction part. UPS is very essential nowadays. It is a device that provides battery backup when the power fails or drops to an unacceptable voltage level. This is the UPS introduction. The switchover time must be small, that is 2 to 4 microseconds, and it's enough to not for breakover in the operation of the loads. Okay, parts of UPS system. Here, the parts of system is charge card, battery, inverter card, display card, EMI filter, stabilizer, buzzer, and last one is fan. Okay, then comes to charger card. It consists of a rectifier which converts AC into DC to charge the battery. This is the block of charge card, and this is the input point. This one is the rectifier, and this is the rectifier output. As a result, DC output, and this is connected to the battery. Battery is the backup of UPS, and it consists of a rectifier. This is the rectifier block, and this is the input main AC supply. When it is applied main AC supply 230 volt, then using here block is rectifier block. That rectifier AC converted into DC, then battery is connected here. That battery is fully charged from the output of DC rectifier. Okay. Then comes to inverter card. Inverter card, it is convert the DC into AC. Okay. Last one is rectifier part. So rectifier part is AC converted to DC, but inverter card, that inverter card is used UPS. That is, it converts the DC into AC. Okay, DC into AC means after battery fully charged, that will back off of the UPS battery. Then battery will output the DC, not AC. Then DC to AC using the inverter block or inverter circuit. That is DC to AC. Okay, DC to AC. It converts the DC to AC. Then EMI filter or filter part. Filter part is most necessary here, and electromagnetic interference. That filter helps to reduce spikes and electrical noise. Okay. Inverter is connected to a EMI filter, that is electromagnetic interference. Okay, it will output pure DC. Okay, this is the AC with noise and spikes. That spikes as a inverter output, which will AC that the use of power transistor, MOSFET. This is the AC spikes and square wave or sine wave. Then inverter after connecting filter circuit, that filter circuit produces the filtration, removing the SC component and getting the output of DC output, that is pure. Then stabilizer, that is regulator the voltage, the constant range, that is shape of the load. Okay, this is the block diagram of a overall EPS system. Okay, and this one is the main AC supply. This is the rectifier block, and here we connect the battery. Okay, and here also practically use one speaker. That speaker is used why is used because the battery voltage is, suppose battery voltage is low voltage, so buzzer also here used here. The buzzer sound, low voltage, in case of low voltage indicates that buzzer sound, and in case of high voltage that buzzer also sound. Then inverter after rectifier AC to DC, that DC will be charged battery, and that DC will connect the inverter circuit or inverter block. Inverter block DC to DC converted into AC, here AC, and as filter, EMI filter, that is going to connect the static switch S2. Okay, that is also pure AC. Okay, now this is the static switch S1, this is the static switch S2. Here static switch S2 is on when AC supply is fails or main supply is fail. Okay, this is the bypass AC. Okay, and this one is the main AC, and this is the overall block diagram of UPS system. Okay, then S2 is on when main supply is fails. Okay, this is the static switch S1 and S2, and this one is the load. Okay, is required load voltage will get. Next part is UPS waveform. UPS waveform, that is true sine wave and modified sine wave, and also use their square wave. Okay, clear? And this is the UPS waveform. This is the main peak point, zero minimum point to maximum point. Then this is the sine wave. Okay, this 0 to t, 0 to t time interval. This is the sine wave. This is the true sine wave, and this one is the square wave. And this wave is the modified sine wave. This wave is the modified sine wave, and this one is the square wave. Okay, and this is the purely truly sine wave. Okay, this is the voltage. Then comes to what are the types of UPS systems. These are two types. One is online UPS and another is offline UPS. Okay, first online UPS. Okay, first part is online UPS. Okay, at first, online UPS. Online UPS system is very essential nowadays. Okay. In this inverter or in this UPS system, online UPS system, normally on and a load is fed by it through static switch. Okay. And in case of hold in the inverters, the load is fed through bypass static switch. Already we have discussed that block S1 and S2, one static switch 1 and static switch 2. Whenever static switch is on, the AC main supply is failure. Okay. So this is the online UPS inverter card always active here. And number 2 is static switches. Static switches, that means switch 2 that is always on, and S1 is generally off condition. When inverter is health, and S1 is also on. S1 means static switch 1 and S2 means static switch 2. Okay. Then offline UPS. Here also major part UPS, online UPS advantages, that is output of inverter can be controlled. Okay. Next part is voltage regulation is better also. That is the advantages of online UPS. And disadvantages, here online UPS is very costlier than other UPS system. Then overall efficiency of CPU is reduced since inverter is always on. Okay, that is the major part of online UPS. And also application online UPS, that is induction motor drives and motor control of application also online UPS used here. And also education sector also online UPS used there. Okay. Next part is offline UPS. Then offline UPS, this is the input is directly connected to output. Okay, input is directly connected to the output. Here also switch S1 also normally on, and while S2 is off. Okay, static switch normally on, but static switch 2 is off, because when mains power failure, okay, then S2 is on. Okay. But online UPS, in compared to online UPS, S1 is generally off, but S2 is always on. Then S1 is on when inverter is fails. But offline UPS, S1 is normally on, S2 is off. When main failures, S2 is static switch is on. Okay. Then third part is there is a switch over time of 2 to 4 milliseconds. Okay, this is the offline UPS, overall offline UPS. And also offline UPS, upper bypass switch is normally on, and the lower one is normally off. Okay, already we have discussed. Then when AC main supply is not available, the inverter is automatically on. Okay. Then it fed power to the load from the battery through static switch. Okay. That switch takes around 2 to 4 milliseconds to connect the load to the inverter. Okay. And offline UPS advantages also. Offline UPS are not very costly in compared to online UPS. Online UPS is very costly, but offline UPS is not very costly. The power hand capacity of charger is reduced. Okay. In compared to online UPS, that is reduced since inverter is always on. Okay. Next, disadvantages of offline UPS, that is the main part. Output of offline uninterruptible power supply is not perfectly and reliable also. Okay. Here also application offline UPS, computers, printers, and scanners. Okay. Then emergency power supply also, EPABX, electronic private automatic branch exchange, telecom sector also used here. Okay. This is the overall block, the online of offline UPS, and explained also and discuss also. This is the main supply, and this one is the rectifier block, and this is the battery. This is the rectifier output, that is DC voltage, and going to connect the inverter block. Okay, then inverter is DC to AC. Here we connect filter, EMI filter, that is the pure AC. That switch is S2 static switch. Okay, and this one is the load also, and this is the switch 1. Okay, already we have discussed. Clear? Now comes to overall UPS system applications. UPS system generally used where the data loss poses a serious problem like computers, operation theaters, banking sector, control room applications, telecom sector, education sector. Okay, many more applications here. This is the difference between UPS and inverter system, and UPS or inverter, that is the comparison between UPS and inverter. Here UPS, it has high switch speed and very low switch cover. The time is 2 to 4 millisecond. Here inverter is, it has low switching speed and high switch over time, that is 20 to 40 millisecond. Then it is UPS is, it is used for computer applications, but in compared to inverter, that is used for home appliance, like that television system, fan, and tube light also. Okay. And UPS system, their used output is sine wave, but inverter output is square wave. In compared to use the sine wave, that sine wave circuit is very costly inverter. Okay, but overall used output is square wave. Okay, clear? Thank you.